Quantum Mechanics by YKademy. In our day-to-day life, we intuitively understand how the world works. Drop a glass and it'll smash to the floor. Kick a ball and it'll roll along. Walk to a wall and you can't walk through it. There are many laws of physics that happen all around us that we all instinctively grasp. Other phenomena that we see every day are gravity makes things fall to the ground, pushing something makes it move, and two objects can't occupy the same space at the same time. These are phenomena that make up all the laws of classical physics, but do they apply to everything in nature? At the turn of the 20th century, many scientists believed that these basic rules should apply to everything in nature, but then they began to study the world of the ultra-small. To put that into perspective, that's on the atomic or subatomic level. Atoms, electrons, light waves, none of these things follow the normal rules. As physicists such as Niels Bohr and Albert Einstein began to study particles, they discovered new laws of physics that were downright counterintuitive. These were the laws of quantum mechanics, and they got their name from the work of a physicist named Max Planck. Quantum mechanics is a body of scientific laws that describe the behavior of photons, electrons, quarks, and other particles that make up the universe at a quantum level. This field of physics gradually arose from theories and questions to explain observations which could not be reconciled with classical physics, such as Max Planck's solution in 1900 to the black body radiation problem, as well as the correspondence between energy and frequency in Albert Einstein's 1905 paper, which explained the photoelectric effect. Early quantum theory was profoundly reconceived in the mid-1920s by Erwin Schrödinger, Werner Heisenberg, and Max Born, as well as other scientists. Quantum mechanics has brought a few revolutionary principles to light. Number 1. Quantized properties. Certain properties such as the position, speed, and color can sometimes only occur in specific set amounts, much like a dial that clicks from number to number. This challenged a fundamental assumption of classical mechanics, which said that such properties should only exist on a smooth continuous spectrum. Number 2. Particles of light. Light can sometimes behave as a particle as well as a wave. This was initially met with harsh criticism as it ran contrary to 200 years of experiments showing light behaving as a wave. Number 3. Waves of matter. Matter can also behave as a wave. This ran counter to the roughly 30 years of experiment showing that matter, such as electrons, exists as particles. Number 4. The uncertainty principle. This principle tells us that matter has certain properties, such as an electron's position and speed, are complementary, meaning that there's a limit to how well the precision of each property can be known. This reasons that the more precisely an electron's position is known, the less precisely its speed can be known, and vice versa. Quantum mechanics also introduced many other important discoveries, such as the Standard Model of Physics, Planck's equation, wave-particle duality, antiparticles, Schrödinger's wave equation, the atomic structure, and various properties such as particles can exist in two places at once, particles can pass through solid objects, and many other peculiar laws. The study of quantum mechanics is rewarding for several reasons. First, it illustrates the essential methodology of physics. Second, it has been enormously successful in giving correct results in practically every situation. However, an intriguing paradox is presented as in spite of the overwhelming practical success, the foundations of the subject contain unresolved problems, in particular, problems concerning the nature of measurement. Thus, quantum mechanics attracted some of the most ablest minds of the 20th century, and they built perhaps what is the finest intellectual edifice of the period. I really hope you enjoyed the video, and if you did, don't forget to like, comment, and subscribe.